Hello friends, welcome back to the bench. Thank you very much for joining me. Our patient is a 2011 Chrysler fuse box, essentially. This is essentially fuse box. Well, not essentially, this is fuse box, right? So this is the whole box that goes, all the fuses go over here, right, on this little plate, all right? This plate connects to this plate, right, and this plate connects to this plate. Now, this is 2011, so it's not super old, but especially those older ones, and Ford, Dodge, Ram, everything from the older, especially trucks, those SUVs, right? It's very common that something will stop working, like the auto lock, the doors don't lock or unlock, the power windows are not going down, the tail lights are going on and off, and typically what you will hear people suggest was, check the wiring and stuff, right? But wires, if you don't touch them, they don't really break that much. The majority of the problems always comes, well, almost always come from the fuse box. Now, all fuse boxes are built a little bit differently, but the general idea is the same. We have plenty of fuses, and they need to be in the circuit with some load, right? So depending on what they protect. But in addition, on some of these, like this one, and actually this is relatively common, we also have relays built in to the box. And these relays, they can go bad. Relays can go faulty. There are a few ways they can go faulty, but just quickly, we have a fuel pump, right? We have a front wiper, one of these, front wiper and door locks, right? This one, a front wiper on off, and a front and rear washer, and so on, right? This one is also door locks, right? So this one and this one are responsible for locks, right? So how do relays go faulty, and how do we fix them? Well, we don't really fix them, we replace them. But how do we find out which ones are faulty and which ones are good? It's relatively simple. So typically relay is going to have at least, a one pair where we have the coil through which we push current, which changes the state, right? And we have 2, 3, 4, 5 outputs depending on the relay. And we want to see a relay closing at least 2 pins, right? Maybe opening the other 2, or maybe there are 3 pins and we have a center tab and one gets open, the other one gets closed. Doesn't really matter. What happens inside, there is an actual switch. 2 pieces of metal are touching to create the connection. Now, those metals are made in the way that they don't oxidize, they don't spark, and all that kind of stuff. So they are long lasting. But long lasting doesn't mean they last forever. So what happens? There's either a buildup on those contacts, or those contacts sometimes completely through the sheer force, the repeated cycle of closing and opening, those metals just hitting each other, they just break off, right? And so the relay can completely stop closing the circuit. The relay can have a problem with the control coil, which means you touch the 8 volts to it and you don't hear anything, right? Nothing's happening. That's the coil went bad. But if it is clicking, doesn't mean it is working. So what you need is a good milliohm meter. And what you want to see on the milliohm meter, because you could use like regular multimeter and beeper and stuff, and close the switch and hear the beep and conclude that, okay, it works. But no, you have to make sure that we have near 0 ohms on the contacts, because they will close, and that could be enough for your beeper to beep, but instead you see 5 ohms on it, right? Obviously that's not good. But I like to use milliohm meter because it's a lot more precise, and what I want to see on the milliohm meter is the maximum of 2 milliohms. Actually, I prefer to see 0, like plain 0, but there is also, you know, certain length of the contacts and stuff, so I allow 2 milliohms to be present on the contact, no more than that. Now 50 milliohms is relatively a lot, but again, you're not gonna see it with a regular multimeter. Regular multimeter will likely just show you 0 or 0.1, and you'll conclude that it's good. But 50 milliohms is a bit too much. 100, 200 milliohms, too much. So that's what we gotta do. But first we have to desolder all these relays, because we can't reliably check that in circuit. It's not even because the circuit would interfere with our measurements, but there's basically no way to actually physically do it. I can't manipulate nicely enough over here to connect the wires and actually check the resistances and stuff. So we have to dig them out. Number 1. Most of them are doubles, so they have 2 coils. So these are essentially 2 relays in one package. Now one thing, let's mention what also happens, because this comes with the entire, you know, every single relay needs to be removed off the board, and there's plenty of them, right? What I do, I take a picture on top of the having a little cheat sheet over here, obviously. I also take a picture or a few pictures so I can know how to reassemble it easier. But just using this, we can reassemble it correctly. The sizes and the amperage of each relay is printed over there. But what also happens, which should not be underestimated, sometimes you see stuff like, is this the one? Yeah, it's not. I thought it was this one. So you will see some signs of corrosion somewhere, right? And I had one over here that was very badly corroded. Was it this one? Maybe. By corrosion, what we mean, you see that gunk on it? That's going to prevent a good contact. So obviously the entire thing is going to the ultrasonic cleaner just to prevent stuff like that. But definitely, so this is what it should look like, right? You don't see any gunk, it's shiny. Obviously it's a little bit, you know, worn, but that's what you want to see. Now you don't want to see all this gunk. And this particular one that had plenty of gunk on it, oh, this is the one, I think, yeah, there. See all this gunk? This one's bad. It probably was still working, but that tells us that there was, most likely it's from the liquid. It basically looks like liquid damage, right? But it doesn't mean that something spilled on the fuse box. It's from the humidity. And this particular one is from the cigarette lighter, or they call it outlet now, because no one uses it as a cigarette lighter, because no one smokes in their cars anymore. But that means that you're gonna, after this, you're gonna have to check your cigarette lighter in the car. This is for the rear, I think, because it says outlet 2. I'm not sure. I'll double check that. But it's either it probably has one in the front, one in the back, for charging your phone and stuff like that. So something is wrong there. We have abnormal current draw on that. Now it also could be explained by just heavy use, right? It doesn't have to be abnormal. It is abnormal as far as we see over here because the fuse looks really bad. So something was bad there, but maybe, or you see, there's another possibility. If you use a tire inflator and you connect it to this outlet, right, to inflate the tires. If you use it a bit too heavy, a bit too much, this could be the result. Now, we don't know exactly what's wrong with the car, like which things don't work, like the fuel pump or doors or whatever. That way we would just address particular relay, but that's even better because we have to check all of them and confirm that all of them work. If any of them is faulty, it's showing higher resistance, we have to replace it. So first we need to do that. So it's even better when I don't get the actual description of the issue, because then I'm biased towards this particular circuit, and sometimes it can be a wild goose chase. It could be a little misleading. So I even prefer it that way, especially, well, for this particular service. Now, the service is not very cheap because it takes a lot of time. Look how many fuses you have to remove. The disassembly of this entire assembly is also relatively time-consuming and difficult and frustrating. And we have to do the ultrasonic cleaning, and then it's very time-consuming to desolder and resolder the relays. So yeah, it's not cheap, but it saves you thousands of dollars on mechanics, especially if you have problems like I described, a little older car and stuff doesn't work like it should be. Power windows, auto locks and all kinds of stuff, and especially intermittently, right? Sometimes it works, sometimes it doesn't work. That's usually gonna be a fuse box rebuild issue, or it's gonna be fuse box issue and rebuild is required. All right, let's roll the footage and get it done. Alrighty, all relays are out, the board is clean and ready for the new ones. Now I checked them, and some of them in the teens, some of them in the hundreds. So definitely, well, some of them I actually would even keep, meaning they don't necessarily require replacement. But since it's already out, I'm just gonna replace all of them. They're not very expensive. That'll make the car last longer, so we don't have to repeat that in the future. And this is not a cheap service, guys. Mainly because it requires so much effort, so much time. That's one thing. But since I don't see any relays that would either not work completely, intermittently work, or just show high resistance, I think your actual problem was here. And this is usually what we do when we do the fuse box rebuilds. See this green copper over here? Yeah, that was most likely your problem. So it probably wasn't relays. I mean, it's not a bad thing to aim for the relays, right? We have a little more over here, but that's tiny compared to a little more oxidation here or corrosion. But it's tiny compared to the other one. So all of this is going to the ultrasonic cleaner to remove all the corrosion. And we're also going to put some deoxide on it to clean the metal very nicely before we put it back together. This is actually more common that you have a corrosion, or, well, not in this case, because in case of this one, all of the pins are pressed, right? They're not soldered on. A pressing method is actually a lot more reliable than soldering, because solder will crack after a while. It also is impacted by the temperature and temperature fluctuations and all that kind of stuff. So the solder will eventually be a point of failure in any connection. Pressing them, it's much more reliable. It lasts for a lot longer. So pretty much all of the components that go into space or are basically transported somewhere where maintenance is very difficult, they're always pressed. They're never soldered. But on especially on some Dodges and Rams, I think Rams are really notorious for this. Some Fords as well, where the assembly is actually soldered on. So these parts that actually hold the fuses, they are soldered on the other side. And especially when after years of replacing the fuses, you put some tension on it, the solder is going to start cracking on the other side. And that is notorious for some models and years. But no car is immune to this. Eventually, after a while, if your car is experiencing weird electrical issues, intermittent windows working or something like that, that's most likely the reason. So this is always something to always think about when you're when you're experiencing issues like that. All right, I'm not gonna be replacing the fuses right now because they need to get to me. I don't keep them in stock because it's very rare that I do these. Anyways, thank you guys very much for watching. I do appreciate you, and I shall see you guys in the next one.